Hi class, it's Miss Aarons here. Sorry it's so late for me doing this video. My computer ended up crashing and I lost the video, so it didn't upload, so I'm going to go ahead and redo it and upload it here from home. So let's go ahead and talk about this key vocabulary. I'm not going to go ahead and write all the definitions for you. I'm just going to talk about them and kind of show you again what they are. So remember, a spectator ion, we talked about spectator ions today. And a spectator ion is just an ion that does not partake in the chemical reaction. Okay, then we have our activity series. Activity series, we use these in single replacement reactions. Here's an example of the one that we printed out for you. Okay, and remember that if it is above whatever it's trying to replace, it will replace it. If it's below it, it will not. The reaction will not happen. Okay. So, solubility. We do have our solubility rules. Remember right here, here is our solubility rules. Okay, this tells you if it's going to be solid, liquid, gas, or aqueous. Pretty easy. Remember to look at those polyatomic ions again if you do not know them. A catalyst is something that speeds up a chemical reaction. We have a reactant that is going to be our starting material. Our product is going to be our ending material. Then we have our net ionic equation. Our net ionic equation is going to be the equation at the very, very end when we're doing the what we did today. So you cancel out the spectator ions, and then the ions that are actually reacting are the only ones that are left. We have a chemical reaction. Remember that indicators of chemical reaction: color change, temperature change, formation of a precipitate, formation of a gas, all those. So those will be on there as well. Coefficient. Those are the big numbers that we put out front when we're balancing chemical equations. Subscripts are the small numbers for when we're doing the crisscross. States of matter directly correlates with solubility, and that's going to be solid, liquid, gas, or aqueous. Remember, aqueous is a mixture, which is right here as well. And to make a mixture, you have to put the solute into the solvent. Okay, so remember those. Those are mixtures. Solute, solvent, and mixture are all from chapter 1, taking it back a little bit. Okay, the next part that we're going to talk about are the 5 types of equations. And a little bit of characteristics of each. And I'm going to blend 1 and 2 together here for you as well. So we're going to talk about those. So the 5 types first. Let's go through those 5 types. Okay, we have double replacement. We have single replacement. We have decomp, or decomposition. We have synthesis, and we have combustion. Okay, those are our 5 types that we're going to talk about. Double replacement. Start off with double replacement. Remember, we had the simple A and B, plus C and D produces AD plus CB. Remember, these are going to be 2 aqueous ionic compounds, and you should form a solid and then something else that is aqueous. Okay. Also, neutralizations are the same thing, and that's when we have our acid plus our base, and we get a salt plus water. Remember, this water is liquid, so if you have to do the net ionic or complete ionic formulas for this, you cannot split this apart because it is a liquid. Single replacement reactions, remember, metals replace metals, nonmetals replace nonmetals. So we would have AB plus C. And if C is a nonmetal, then it'll replace the nonmetal. If it's a metal, it'll replace the metals. Okay, so we're going to say it's a nonmetal right now. So we'd get AC plus B. Decomp is the divorce. We would have AB, and they're breaking apart into A plus B. Synthesis is the exact opposite, and that's a marriage. So we have A plus B equals AB. And then lastly, we have combustion. Combustion, you always have your hydrocarbon, so that's carbon attached to some sort of hydrogen, plus our oxygen, O2, and that is going to produce CO2 and H2O. Remember that these are always the products. Okay, don't forget that. Those are always the products for those as well. Let's go ahead and skip down to number 3 here. Okay, the correct ionic formulas for the elements below, then state if they are aqueous or solid, then write synthesis reaction that would happen in between them. Okay, so we have barium. Barium on the periodic table is a solid because it is black. We look at fluorine. The reason I'm putting that 2 there is because it's a diatomic molecule. So remember, if it's by itself, there's always 2 of them. Fluorine is red on the periodic table, so that is a gas. When we combine them, we're going to do the crisscross. So we know barium has a +2 charge, fluorine has a -1 charge, so we crisscross, and we get BaF2. So if we look at trying to balance this, we have 1 barium, 2 fluorines, 2 fluorines. So everything is balanced. And then let's go ahead and look at those solubility rules and determine if it's soluble or not. This one's going to go with rule number 3 here, and it says most chlorides are soluble except for those of silver, mercury, and lead. Okay, I know fluorine is not chlorine, but remember, if it's in the same group, it's going to react similar to it. So we know that that is going to be aqueous. Okay, the next one is going to be lithium and nitrate. So we have Li, which is a +1 charge, and that is going to be solid. It is black on the periodic table, plus nitrate, NO3, -1, and I know that's aqueous. Nitrates are always aqueous. That is rule number 1 on the periodic table. And then we can go ahead and we're going to crisscross these. So we get LiNO3. And that is going to be aqueous as well. We try to balance them, 1 lithium, 1 lithium, 1 nitrate, 1 nitrate, we are good to go. Last one, we have iron 2 bromide. So it's going to be Fe with a +2 charge, and that's going to be a solid. It's black on the periodic table, plus bromine, Br2. Again, I put the 2 there because this is a diatomic molecule. If you remember those diatomic molecules, there's 7 of them. Okay, and they form that 7 on the periodic table. And bromine has a -1 charge. Bromine is actually a liquid. It's blue on the periodic table, so it is a liquid. And we can go ahead and crisscross. So we get FeBr2. Okay, bromine is going to act like fluorine. Okay, it's in the same group, so it's going to act like a chlorine. So that is actually also going to be aqueous as well. Okay, next part, we're going to look at the solubilities to determine if it's soluble or not. When you're looking at these solubilities, a little hint here to help you is that you really do need to look at the ending part. That ending part is really going to give you and tell you if it's soluble or not. So if you can look at this and you can name that and you say that's a carbonate, okay, that's carbonate, you can look at those solubility rules and go, okay, right here, rule number 5, most carbonates, phosphates, and silicates are insoluble except for those of sodium, potassium, and ammonium. Okay, so they're mostly insoluble. So what was that carbonate attached to? Well, it's attached to a beryllium. So that means it's going to be insoluble. So that means it is a solid. Okay, now we have sodium sulfate. So we're going to look at that sulfate, go back to your rules, find sulfates, that's rule number 4. Most sulfates are soluble except those of barium, strontium, lead, calcium, and mercury. Okay, well that's sodium, so it's not part of the exception, so that means it is soluble. So that's going to be aqueous. And lastly, we have oxygen. Oxygen is in the same group as sulfur. Okay, so we're going to go and look at our solubility rules and find sulfides, and it says most sulfides are insoluble except those of calcium, strontium, sodium, potassium, and ammonium. Well, that oxygen was with potassium, so that means it is going to be soluble. So that is aqueous. Okay, now we can look at our activity series and figure out if these single replacement reactions are going to occur. So we have cadmium, and remember, these single replacement reactions, metals have to replace metals and nonmetals replace nonmetals. So this is a metal, this is a metal. We have a metal here, metal here, metal. Okay, the other ones are nonmetals. So this is a nonmetal, this is a nonmetal, this is a nonmetal, and this is a nonmetal. And I know that it's a nonmetal or a metal just by the location of the period on the periodic table. So if you look at your staircase, we colored that red on your periodic table. Anything from that staircase all the way over is going to be a metal. Anything on the other side of that is going to be a non-metal. So metals are going to replace metals. So cadmium is trying to replace iron. So cadmium has to be higher than iron on our activity series. So we find cadmium on here. Let's see, right here, here's cadmium. Here's iron. Cadmium is lower than iron. So that reaction is not going to occur. So you can go ahead and put no reaction. Okay, now we're going to do aluminum and lead. Find it on here. Aluminum. I found lead. An aluminum, okay, there's lead. Here's aluminum. So aluminum is higher than lead, so that reaction will recur. So we can just go ahead and put reaction. And then we have fluorine and iodine. Fluorine and iodine, and those are both nonmetals, so we have to go to the nonmetal side. Also, that's another way you can determine if it's a metal or a nonmetal is over here it says activity in metals. This side it says activity in nonmetals. That might help you as well. So fluorine is actually higher than iodine, so that reaction will not occur. So no reaction. Okay, next part here. It says circle the reactants, box the products. Okay, so reactants are always on the left-hand side. There's our reactants. Here's our products. Pretty easy. Next up after that, it says predict the products of the following equation, write the formulas correctly, and then label the states of matter of each compound. Okay, and I'm going to go ahead and balance these while I do it as well. I'm going to add a couple extras returns in here so I can make sure I have enough room. Okay, so our first one we have nitrogen. And nitrogen is a diatomic molecule as well. And when we look at the periodic table, it is red, so I'm going to go ahead and make that a gas. Hydrogen is also diatomic, and that is also a gas. So we have two of these coming together. And so we have two nonmetals forming together, so that's actually going to be a, I guess you could do it either way. We can do it as a covalent bond or an ionic bond. They will transfer, kind of share those electrons as well. So we have nitrogen that has a -3 charge, and hydrogen that has a +1 charge. So we can crisscross applesauce and we get H3N. So that is actually hydronitric acid. So that is going to be aqueous. Okay, now we can go ahead and balance it. We have 2 nitrogens on this side and only 1 on this side, so I'm going to put a 2 out front. So that gives me 6 hydrogens and 2 nitrogens. And then from here, we have 6 on this side, so we're going to put a 3 out front there. Then we have HCN, which would be cyanidic acid, or hydrocyanic acid, sorry, and then copper sulfate. So this is going to be a double replacement reaction, which means here's our metals, here's our nonmetals, and they're going to replace each other. So hydrogen has a +1 charge, SO4 has a -2 charge, plus copper, which is going to have a +2 charge, and cyanide has a -1 charge. I know that copper has that +2 charge because there is no 2's down here with sulfate, and I know sulfate's charge already. So we can go ahead and crisscross. We get H2SO4 and then CuCN2. So we know that this is an acid right here because there is an H out front, so that's going to be aqueous. Copper sulfate, that is the salt we use in our lab, so we know that is going to be aqueous. And then we have sulfuric acid, which is going to be aqueous because it is an acid. And then copper cyanide. Cyanide's not on there, but cyanides are normally always solid unless it's on there. Don't worry, you won't ever have a cyanide on your tests, but it is a solid. So now let's go ahead and balance these. We have 1 hydrogen here and 2 on this side. So we're going to put a 2 out front here, so that's 2 hydrogen, 2 cyanides, 1 copper, 1 sulfate, 2 cyanides. We are all good and balanced there. Next, we have gas.